you so much, Claire. All filled in. And it was asking two questions. One was, what's going well for this class? And then what isn't going well for this class? And I'm very, very glad that, that everyone took time to actually to contribute to the survey. The survey was not mine. The survey was from the college. And the survey was, I think it's important to receive feedback from students. And the survey was anonymous. And so the feedback should be more or less what the students are thinking, I think. If you ask somebody, how are you enjoying this course, or what are you not enjoying this course, I tend to find that everyone is they don't exactly say what it is that's really on their mind. But if you have an anonymous survey, then it seems to help. And so thank you very much for actually providing some honest information. And one thing I would like to address is that some people were saying that this class should have had a requisite. There should have been a requisite for programming in this course. And while it's a very good idea, and I think that I mean, this is a computer science course, and it's arguably quite a complicated course at that. When I first put this course together, I didn't want a requisite for this course. In fact, I wanted a data analytics course for this department, because I found that there are many people, not just students, but also faculty, who were working with data. And I thought that this is something that I could do to really help people work with data. This all actually comes out of a conversation that I had with somebody when I first arrived. This person was working with data in different ways. And they were saying that they had so many problems with working with data, and they just couldn't figure out what they could do to plot their data, basically just to make really good plots. And I thought, hey, this is probably an issue that not just this person is having, but maybe a lot of faculty here, and maybe a lot of students are having this problem too. And so this course actually was born out of the idea that it could be a workshop for other faculty members, other researchers in STEM, or I was thinking economics, biology, physics, chemistry, obviously computer science, but I was thinking that it'd be for those kinds of areas. But then I thought, actually, that's kind of limiting here. I wanted a class that would actually be more open to everybody, to every single person, because we all share this world. We are all here together, and we all work we all work with data in some way. And I'm thinking that this will not stop. You will be working with data throughout your careers. In fact, I'm fairly positive that wherever you go in this world, wherever your career takes you, someone is going to give you a computer and a bunch of data, and they're going to say, "Tell me, what do I do? What should I do with this data?" And your job will be to save that company in some way here, or to save your shareholders, or to save the world, to save government, or whatever it may be, to save something, but it'll be by making decisions which are based upon your analysis of that data. And so because of that, I didn't want to have a requisite in this course. I wanted to have this course open to anybody, whether they're going to be going into careers in computer science, or whether they're going to careers in some other area. That really didn't matter to me. I wanted people to be able to come into this course and learn how to work with data, regardless of the origins of that person's discipline. So really what I'm trying to say, though, is that there are no requisites for this course based on principle, because I wanted it to be really open to everybody, because we all work with data. We all have interests in working with data and doing something where we're trying to figure out how to make a decision based on numbers. And so that's really what this course is. Now, one of the side effects of such a course is that you have to have some kind of computational means. You have to have some ability to work with data. And while many people in the beginning suggested that I use something like Excel, this department is not a Microsoft department. We don't have any Microsoft products here. So we don't, we have our machines traditionally were all Linux. And so then I wasn't thinking about Excel. But then I thought, actually, Excel, if you wanted to use Excel, you'd have to pay for that. So that means that if you wanted to work with somebody who's giving you a spreadsheet, you would have to have Excel too. And I didn't want to have people have to go out and buy software. So then the idea came that, well, what about something open source? Because that's more in tradition of what we're doing here with Linux in our machines. I mean, I know now we have our own, you can bring your own devices in, but before when we had machines here, we actually had Linux machines. So then I thought, well, what about like an open source language like R? I was considering R and Python. I thought maybe R, because R is actually a very industry standard. It's a good computational platform to do data analytics. And also we have other courses that I teach which do Python. And so I wanted the students who come through my courses to leave those courses with Python and R, because I think that those are both very strong languages to have productive careers. But for this course though, I chose R. And the reason for that is because it's free. If you wanted to collaborate with anybody, you didn't have to actually go out and buy R, you just downloaded it. But with that came the costs of actually spending time learning how to use R. And so this course has been structured in such a way that we do some data analytics, but we also spend some time to do R. So for instance, your last lab that we had where we were doing R problems, that was designed to give you a kind of a taste of how R comes together. Now, I do apologize for the difficulty in that lab and making all the, in putting code together. And I think that there is just inherent difficulties in learning how to use, whether it's a computer language or whether it's a human language. You have to get behind the keyboard and kind of practice with R to become proficient at it, just as you have to practice with human languages in order to have a conversation. And so, yes, there could be a prerequisite to help people to learn how to use R, but I think though that in interest of having the class open and available to any major, I forewent that, and then I just thought, well, we'll just teach R in this class. And so the long story short, is that don't give up. When I first saw R, I had this allergic reaction where I practically broke out in hives, and I thought this was like a terrible, terrible programming language. I'll never figure this thing out. But I did, and I'm thinking that if I can figure out these languages, then anybody can. I mean, anyone, anywhere can figure out how to use R. I know that doesn't sound like I have much confidence in my own intelligence, but what I'm saying though is that anyone can figure this out. And I think though that if you look at the slides in this class, if you spend time actually looking at the examples, I've put together slides or examples in the slides where that's the R code you need to do this kind of work. One last thing that I'll say about R is that there is it is difficult to learn this language. It's difficult if you're not coming from computer science in terms of you know what you want the data to do. You want to move this column over here, and then I want to move this data around over here, and I want to do all these other things. And so while that's something that we know how to do, it is always difficult, even for seasoned programmers. It's difficult to think in terms of what's the actual code that I have to type in to make that happen. And so I think that if you just keep going and you don't stop and you just look at the slides and you just concentrate on maybe what the code is actually doing rather than trying to memorize the code, then I think that you'll be okay. I think that you just have to kind of just keep going with it though. But don't give up. Don't give up on yourself, and don't give up on the code here, because things will make sense. We'll come into the light, and I think that it'll be a rewarding experience for you. It will be challenging and painful to get through some of this R code, but if you just keep your eye on the slides, then the information that you need to actually get through that code will be there. And so I'm thinking that it's not going to be, it's going to be a challenge, but just keep going. Don't stop. Don't get stressed out. If it gets, I find that, for instance, if I get stressed out, and I do get stressed out with my own code, I take my dog out for a walk, which seems to do the trick. And when I'm coming back, I have this idea like, oh, wait, what if I try this? And so what I'm saying is that just get some air. If you're feeling the crunch because you're working on your code and it's not working, then get some air, and I think that everything will be okay. But remember though, this course is open to anybody. It doesn't matter whether you're a computer science person or not. And one thing I will say though, is that the speakers that we've had so far, Ron Maddox and Dr. Yimon Thu, they do data analytics. And in conversations I've had with both of them, they've said that they've never had a class like data analytics. They've never had a class where they're learning how to deal with data. And so they say that they wished that they had learned some of the code because they had to figure this stuff out for themselves. And one of them said that was just really painful. So I'm hoping that while it is difficult to learn a computing language, I'm hoping that this actually makes it fun, interesting, but also it's going to be rewarding for you once you've graduated. Anyway, I don't want to keep harping on this whole thing here. If you have questions, we can discuss this further. I do have office hours. There's Slack. You can meet me on Slack. You can we can discuss any troubles that you may have in your code. I don't want you to be sitting at home getting stressed out because that's just not fun. But I do ask though that if you send me a message, if you're getting an error message on Slack, don't just send me the error message, but actually send me or send out to the class if you want, or your technical leaders, but send out the context to the problem, like maybe the code that you typed in, and then we'll have an idea about why that error message came up. Anyway, you do have really excellent technical leaders. You have me, you have each other. We'll get through this. We'll get through this. All right. So anyway, that's that. So that was from the survey. And so I just wanted to make that point. The other main point that I wanted to talk about were the lab grades. It just takes me so much time to read all these lab grades and get the results back to you. I am working on it, but you do not need the labs for your to be successful on your test. They're completely apart from everything, but you will have those results very, very soon. Hopefully by, well, in the next couple of days, we'll see. But I am trying, and I'm aware. But it's just that I'm on so many committees for this COVID-19 safety watch that we have. Sometimes it's difficult to find the time to actually sit down and do all the grading. And there's about 40 people in this class, and so it takes some time to actually go through each person's grade. And I do go through each person's grade to try and find any faults I may have made and fix any errors, but sometimes errors do happen. So once the grades are out, please do check. Anyway, again, I'm available and you can talk to me if you have any questions. Let's go through the slides for a second here. I wanted to talk about the exam that's coming up here. The exam details, actually this title isn't correct. I don't think it's where we were before, but this is week 6. We're going to stop week 5's slides temporarily. We'll return to that. But I wanted to have the exam coming out this week. And that is because I need those grades for my own grade books, because that's, you need those numbers by next week. That's about it. So we have our tests. In fact, our test is actually, you can see that it's on it's on the planning your time if you go to data analytics. And if you go to the planning your time schedule, you'll see that week 6, we do have our exam. And so that it's to be announced, but I'm actually saying that it's going to be on Thursday, the 8th. But I'm going to make things interesting here for you. I don't want this to be a hindrance. I know that everybody here is very busy. In fact, some of us are not even in the same time zone. And so we're really spread out all over the place. And so you have from the class time on Thursday, 11:10 a.m. to Friday at 4:30 p.m. That's the end of lab to complete the test. You have so that's a whole bunch of time here. So that's like over 24 hours. And so you have all this extra time here. And so I'm hoping that in that time, you'll find some window where you'll be able to complete this test in some convenient time for you. I will say that you will not need over 24 hours to complete this test. It's not that kind of test. This test was actually given, or actually a similar version of this test was given, I think 2 years ago. And I gave the students, I think, 1.5 hours to take the test, but if anyone wanted more time, they could easily have it. As you know, I'm not interested in the amount of time that it takes you to take a test. I'm interested in answers. And so I don't usually have like hard and fast rules for my own exams on how much time you have to take these things. And so if you want 1.5 times, you can have 1.5 times. You can have more time than that if you need it. But but for the final exams, though, like I can't change those times, and so there's some problems. But for my own exams, though, for exam 1 and 2 here, you can have as much time as you want. And here you get about almost 28 hours, I guess, to do this. Well, more than that, actually, almost like 1.5 days to get this thing done. And so I'm thinking that in that time, you should be able to find like 2 or 3 hours, or you can break up the time if you want to get this thing done. So hopefully that sounds fair. I hope that sounds fair. And I know that you're all busy. You have other classes going on. And actually, the reason why there's so much time here is not just because students are in different time zones, but also I'm sensitive to the fact that during this same week, we have professors in, I think, economics, and chemistry, and physics, There's some other majors in this class I'm trying to think of now, and I just can't remember what they are. Oh, and computer science too. But there are a number of different departments giving tests this week. I'm getting some nods in here. Getting some nods. What class are you in now? So economics. Yeah. So yeah, I think that economics is having a bunch of tests this week, and so I am sensitive to that, and so I don't want you to, I don't want you to to be driven into the ground here, and so I'm hoping that between Thursday and Friday there should be enough time to get this thing done, and hopefully this will help. I don't know. But they will. The details are here. We have 10 to 15 questions. They have multiple choice and short essay. Multiple choice, so they're basically just factual questions where you're looking at code, trying to figure out where the error is, trying to find out what's wrong with them, or find out what it does. For the short essay, you'll be looking at probably looking at plots and trying to make out some kind of reason for why that plot is showing something, or finding out where if there's a pattern there or not. It's going to be that kind of thing. You're interpreting things. The lab material is not going to be on the exam. What I will say though is on the exam is the information from slides. So please do check your slides. And because this is a take-home exam basically for all this time, you can use your slides. I'm not going to tell you you can't use the slides, but I do ask though that you'll be working alone. That means you cannot team up with other colleagues in this class and work together. You have to work individually. That is it. You'll have some questions in R to look at here, and again, this R code, variations of it will be in your slides. You'll be able to look at your slides and kind of get some ideas on how that code should work, and that will be to wrangle data, and by wrangling data, what I'm talking about is moving information around. Oh, you will have we did Google Analytics, and so that's in there somewhere. I didn't put that here, but that's going to be more conceptual, probably short essay types of questions. But you'll have like data wrangling was like moving things around, trying to figure out how you can put I don't know, how you can select certain kinds of columns, using it's like using the select or the arrange or the mutate commands. You'll be plotting, where you're using your code to create plots to try and determine patterns from your data. And really it's all the information that we've covered in this class up to slide 10 of week 5. That was where we left off last Thursday, on slide 10 of week 5. And so anything up to that. Now, after this exam, then we'll hit slide 11 of week 5's slide deck here. And so then we'll be able to pick up and continue. I hope that sounds okay. Are there any questions that anyone has to like to ask? Yes, sir. Okay, so the question is, how do tests work on Sakai? Can you save the test? I think you can. I think that when you're working on Sakai, you can keep going and then you can stop the test in the middle and you can come back to it. I'm not entirely sure about that because I don't see what the student side sees. But I think that does anyone know actually? Does anybody online perhaps? Does anyone know? Okay. So I think I'll look into see how if it can be saved and continued from my end. There may be an option. It seems like every time I check Sakai, though, the options are slightly different. I'll look into that and see. But otherwise, I'm sure that is. I think that the test has to be submitted before it's actually there's this actual submit button at the end. And I think that until that button's actually clicked, then it's just floating around in the ether that is your account on Sakai. And so I think that you can still get to it. I'll tell you what, if there's a problem, let me know. But I think that in the past, I don't think I've ever had any trouble with people like stopping their tests and then coming back. We'll see. I know that's not the answer you wanted, but I think that you can get back to Sakai. Okay, so let's see. So what I wanted to do today, though, is I wanted to spend some time to do some review, primarily to go over some different types of R code. I'm sorry that it's taken me so long to actually get into this review part here, but I think that there were certain issues that I really wanted to discuss with you. things that I think that you really needed to hear. But anyway, here we are with the review. And so I wanted to give you a what's called it's a practical repository. So what we're going to be doing with this is that this is just like the same repository that you'd be using whenever you have your lab. But instead, you're going to be just putting your work into this repository and then pushing it out each time. So there's not a new repository for the practical. So this is going to be up here, this link, your practical review repository. It's kind of hard for me to say, but it's your practical review repository. So if I go ahead and click on this, or if I copy this in, then what it's going to do, it will establish a working repository for me. And actually in the future, what I'm going to do is you'll find in your sandbox a directory that you just have to copy in, and your directory in your sandbox is going to be, your next directory will be called 02 practical. And you just have to copy that into this repository and then push it out. But I'm hoping that while you're inside this repository, you spend some time working in here. And so what we have so far is in this repository, let me just take you through it. You have these build run things. These are your commands. If you want to use R or RStudio with Docker, then you have the commands right here. And then once you run Docker, you're able to see these repositories here. But what we have in here is, this is your file that I'd like you to work on today. I was thinking that you could have maybe 20, 25 minutes to work on this. And then at the end of that time, we'd go through this as a class and put the answers in. Now there is a due date to a repository. You actually do get credit for doing this. So please submit your practical work for a check-in grade by basically by noon on Thursday. So these, I am collecting these things for a grade. So they are important. There is a due date for these, and so and Google, or not Google, GitHub Classroom is actually watching the dates on this. One more thing I'll just take you through, that if you go back to this page here, the data analytics page, if you go to your syllabus, you're probably wondering, well, what is this practical? Where does this come from? Periodically, I'll be giving you these practicals to fulfill your class participation points. And so that's 10% of your grade. And so please do, they're just check marks. Even if you don't get done with it today, just submit what you have, or submit or you can finish the entire thing by Thursday, and I'll check it in. Okay, so I'll leave you to it. If you'd like to work in groups, you can. What I'll do, in fact, is I'll click on the breakout rooms, and so you can discuss these ideas with each other.
A few minutes later.
Hopefully, everyone is more or less back in the rooms here. I'm thinking that what I'm going to do is we'll just go through these questions, and I'll just go piece by piece, and then you can have an idea about the kinds of answers that were expected in these. I hope that everyone's out of their room by now. I think that maybe these rooms actually do automatically close if you're not back in there, but I apologize if you're just getting now and you feel like you've been left behind. That wasn't my intention. But what I wanted to do, though, is in the time that we have left, we have about 25 minutes, 24 minutes, I guess. I wanted us to go through some of the answers here, and whatever we don't cover today, I'll just give you some, I think I probably give you the code for that, just so that you have it. So let's go back and look at the work that we're doing here. So if you're looking at these are the questions that we're working on. The first one is I'll just go back to my my RStudio, and so we can start working there. Perhaps that would be easier to see all the pieces coming together on that point there. So now we have one thing that's going to take you some time is if you haven't installed your libraries, which I find hard to believe now that we're at week 6 already. You should have installed them by now, surely, unless of course you're using a different machine. They may take some time. So I have already installed these on my machine here. You do not need to reinstall them each time you run this code. All you need to do is just click on run for that tidyverse, and then you have this other data set right down, NYC flights. You click on run for that. I'm looking at the screen to make sure everything's actually coming through. And then you have another library that maybe you haven't installed on your machine yet, but this is the Plotly library. And Plotly is a plotting library which allows you to interact with your graphics, which actually makes everything very, very cool. So let's move to the first one here. Show the code to view the column header names. Maybe I'll save this first before I start just leaving it in any old place. And I'll put this in my Practical in class. Hang on, Owens. So the command you want to do is to find the column header names here. Is first of all, you need to, we're working with the data sets here, flights. In fact, I should make that clear, but that's up here. If you just run this flights data set here, we're working with flights, you can see that this is the actual data that we're working with. And so when I'm talking about the column headers, I'm saying, is there a way of actually just finding out what the year, month, day, departure time, and et cetera is? And so that code would be simply just typing in names, let's get rid of all this. Names and flights. And so this is what we're working with. And so this gives you the actual names of the columns. Now you might need to, know what that information is if you are actually going after the data of each of these columns here. In particular, you'll need to know exactly how this is spelled so that when you're going after, for instance, tail num or air time, is that air underscore time or is that air with a capital T time? And so you need to know these things. Next, we're talking about the code which will allow you to actually pull out the first row of flights. Well, to do that, flights, remember when you have this, these square brackets here, you can have information about the row and the column here. But what I'm going to do now is I'm saying, well, if I want the first row, I just put a 1 there, followed by a comma. And oops. And what that's going to do is it's going to give me the very first row. Now, if you don't believe me, you can always go to your flights data set and you can look at the first row. The departure time is 5:17, I see. And so if I go here, I see that my first information here is the departure time is 5:17 and the other one is 5:15, which is exactly what I have here. So I am satisfied that this is my first row. Now, if I wanted to, I'll just take you to another journey here. If I wanted to find, for instance, the first row, the first, second, and third rows, I think I can just go ahead and type in this, and this will give me rows 1 through 3 rows. But remember, though, that you still have to have this comma there because you're saying that I don't care what the columns are, I just care about the rows for now. And you'll see that down here, I'm actually getting the first 3 rows. And so that's just a trick. I'll just leave the answer the way it was here. The first row should be just this answer there. Now, going down here, so you show the code to obtain the first column. The first column is going to be...
I didn't get that. Could you try again?
I usually turn Siri off because I find that she just nags at me, but sorry about that. But the first column we want to have here is going to be flights. And then what I'm going to do is I'm going to not remember it's rows, columns here. But the thing is though that since I'm not actually using rows, I'm just going to put a comma there. There's no information for rows. And I'm going to put a 1 here to obtain the first column. And when I run this, that first column happens to be the year. And that's true because if I go to flights, the year, the flights data set here, year is the first column. And so that's correct. Now again, I keep losing this information. If I wanted to go to like maybe the first column to the third column or the fourth column even, I could write it like this. Now this colon in the middle, while that just looks ridiculous as code, what it's actually doing, oops, maybe I have to do something else with it first. What it's actually doing though is it's making a set here, or a sequence. In fact, I can show you something interesting you can try. If I just type in C1:4 by itself, you can just try this. It just gives you an array of 1, 2, 3, and 4. I don't know why this keeps going down here. I want to keep the code on the screen here. But that's just another trick. And so what I'm doing here is when I put this C1234 into this information over here, into this code here, it's really just saying 1, 2, 3, and 4. The array is being superimposed into the columns detail. So you have that, and so I'll leave that there. Is 1, 2, 3, and 4. So you have that as a reminder. But it's another trick in R. It's another shorthand piece of code that you can use. Now the next is to show code to obtain a new variable called myData. And myData is going to be from the, I want to have the first, second, and third rows of the columns departure time, scheduled departure time, and departure delay. So what does that mean then? So let's go back to the data that we have here. Now remember that I'm looking for, I want the first, second, and third rows. And so these are the first, second, third rows. Okay, it's just the first 1, 2, and 3 rows we have here. But I don't want all the columns in these rows. Instead, what I want is I want departure time, I want scheduled departure time, and I want departure delay. I want those columns, nothing else. And so how do I actually go after this? Well, what you do then is I'm looking at the departure time here, and here's one way of doing this. It's just the kind of robust way, but I see that there's year, which is the first row, month, which is the second, day, which is the third. Departure time is the fourth. The scheduled departure time is the fifth, and the departure delay is the sixth. So really, I'm looking for 4, 5, and 6 row or columns. And so I'm going to go back to my code that I was working with here. I'll just put this in here, flights, and in here I'm going to put, well, let's see, what's the criteria? The criteria is that I want to have the first, second, and third rows. And so what I can do is I can just type in this, I believe. That should be sufficient for here. I think I can add this just to make sure that that actually gives me the first, second, third rows. There we go. I get the first, second, and third rows that way. And I think that I don't always need to have this. Let's just try that. No, I don't. It's peculiar. Sometimes you need it, sometimes you don't. I would just try both ways because sometimes, I mean, I've seen it work and not work. There. So these are my rows, my first, second, and third rows. And so I have that done. Then the next thing I need to do is go after the fourth, fifth, and sixth columns, and I do that with exactly this piece of information here: 4, 2, 6. Or what I could do is I could put 4, 5, and 6, and that should also be sufficient. So I have departure time, scheduled departure time, and departure delay, which is exactly what we need in this whole thing here. Now, I could remove this over here, and I'll just say 4 to 6 inclusive, and that's why that gives me the same information here. And so really there's, I guess, what I'm trying to say is that there are two answers to this. I think these are both going to be exactly the same. And so I'll leave those there. In fact, I can have this one here. So the thing is, if you don't have inclusive, if I wanted to like pick out rows 1, 2, and 5, for instance, then I could just put those information, I just put that information here. And then if I run this, you get whatever it is that you're looking for. Yes, sir. Yes. So the question is, if I wanted to automate things a bit, could I do that? You can. So I'll just say that my rows. So let's say that my program picks out, let's just say let's make it different here. 4 or 3, 4, and 5, my rows. And I'll say my columns. I'll make this different too. I'll say this is going to be 7, 8, and 9. So I have these two new data sets that I've just created. I just lost them on my screen. There we are. They're back. So what I could do is I could have flights, and I'd have my rows. In fact, this is a very good idea. If you have a program which is going to be going after information that your user somehow selects, then, for instance, the user's selection would be parked in this variable here and this variable there. And then your actual code that goes through and finds the information that the user has selected would be this over here. And so that's a very good question. You can actually create your own vectors and substitute those into your flight, and then you have that information there. And you can see that my column at 7, 8, and 9, what is that actually here? So let's see, 1, 2, 3, 4, 5, 6, 7 is arrival time, 8 is scheduled arrival time, and the next one after that is, I'll scoot over there. There we are. So I better think this way. And arrival delay. And so that's where these come from here. Those are my 7th, 8th, and 9th columns. Very good question. Okay, let's move on to the next thing. I'm going to go here, show the code to use filter. Okay, so now things are getting a little bit interesting. So now we're going to use filter. Now filter comes out of you're still selecting things here, and so I think it's your exploration week 4, I think it is, or something. But what you're doing though is you're creating code which is not going to just grab all the rows here, but rather it's going to grab rows only where some condition is true. And the condition that I have here is that the departure delay is greater than 800. And so I think to myself, departure delay, well, what variable actually is that in my data set? And so the departure delay, that's going to be year, month, day, departure time, scheduled departure time, departure delay. That's going to be this one, this column over 1, 2, 3, 4, 5, 6, one over, yes. So how do I actually run that code here? So to make that happen, you need to type in filter. I'll put this in my code just so it's there. Filter. Now the first parameter that you have in your filter is going to be the actual data set, flights. The second one that you're going to have here is going to be the variable that I'm going after here. Now, if I can't remember what my variable was that I'm looking at, a little trick you can try. This is like old school. You're going back to old school R here, which they frown on. So you have to clear up your code after. But we'll see what I mean in a second here. But the let's see, the departure delay is this variable here. That's the column header right here. So if I put flights, my data set, followed by a $, then RStudio gives me this listing of the columns that I can see. You can see them on your screen now. So now what I'm going to do is I'm going to look for, I was looking for departure delay. So departure delay is this one here. But the thing is though that it doesn't, I mean, it'll give you, or may in some versions give you a warning message saying that's an obsolete way of doing things. But it's just one way of like finding out what is the name of this thing. What am I actually looking for? It's greater than 800, so my constraint is going to be greater than 800. And then if I run this, you'll see now that it has chosen, where's my departure delay? That's this column over here on the far right. You'll see that all these numbers, I wish you could do this, all these numbers here, these are all numbers which must be greater than 800 in order for that row to be selected. If that isn't true, then it doesn't select that row. But it's grabbing all information in that whole row while this is true, while that number is greater than 800. If it's not greater than 800, if it's equal to 800, I think it's ignored. Okay. Spelling. Oops, sorry about that. So now the next thing here is number 6. Use or show code to use the select to obtain columns of departure and arrival data. And so what I'm going to do now is I need to use we're not using the filter command here, but actually rather we're using select. Now remember what select does. Select is able to grab columns. Filter grabs rows, but select grabs columns. So I'm going to go select in here, and the first thing, oops, not selected. Autocorrect. Select, what I'm going to do now is I need to say something about what my data set is, which is going to be flights. And then I need to say what the variables are, or the names of my columns are. Now, if you forget, there's 2 ways out of this. What you can do is you can just type in names, and I can type in flights, and that will then, if I run this, I have this information down here, so I can actually see what the names are that I'm looking for. But actually, in this example, I just gave you the names because I know that it's going to be, it will take me time to keep going back and forth, and that's just annoying. So what I'm going to do now is I'm going to go back to, I just copied those, and I'll go back down to here, and I need to make a vector, just because that seems like columns have to be vectors, whereas rows doesn't necessarily have to be. Don't forget that all pieces in this vector must be selected, or must be separated by commas. I hope I can make this a bit bigger here so you can see. This should do it. This should do. So if I run this, select flights, and inside here, these are the actual column names that I'm looking for. They're actually put inside a vector, and then that information is then sent to this select command, and I think that it should be good. So here we are. It works. Nice. So what we've done is we're able to actually, we're pulling out, notice that we're not pulling out all columns, but rather only 4 columns of our data set. But we are pulling out all rows. In fact, there are 336,766 more rows to go after. What is that number? Well, if you go back to your flights, I don't know if you can see where I am down here. But this number down here, the number of entries, this is telling you how many rows there are, or how many observations, you could say, there are. And so while you cannot see all that information here, R is trying to make it clear to you that there's still more that it's not showing you. And so hopefully that provides some help. Up next, what we're doing is we're talking about plotting. I think that plotting is actually quite interesting here, but I will say that plotting sadly does take some time to do. And so don't despair. If you ran your code and it's still crunching through, it doesn't mean that your code was wrong. It just means that it just takes some time to get through. We're going to be using this command here called Ggplot. And we're going to be using also this other one here called geom line. And so you have online, in fact, if you just go ahead and if you just type in a question mark before these things here, you'll find that down here, you'll have some online help, which will help you to remember what the code is that I'm supposed to use to actually make this happen. And so you have this demonstration code down here, which I find very helpful. It's very, very helpful. But never mind that. What I'm going to do is I'll just go through and I'll just put in this here. So what I need to do in my Ggplot, first of all, let's get the actual question on the board here. I need to prepare plots of, again, we're using flight data here. And so I'm going to put in flights. Sometimes in some data, in some tables you'll find, or some books, it says data equals flights. But I think that you don't need to worry about that anymore with this version of R. I think they've kind of made it more accessible. So your first thing here is the data. And then what you need to do is you need to put in this command right here. And so you're stringing things together. This plus is basically stringing everything together. And so what I'm saying is prepare to plot this thing. But before you can do that, I need to figure out where all the pieces are going to go on my canvas. And so my canvas is going to have, first of all, in fact, you have in your notes a cheat sheet that I put together for you. But you have this mapping function. Mapping function is going to be speaking to another function called the aesthetics function, AES, I believe. And inside my AES function, let's see, what am I doing here? Okay, so I have to define my X variable here, and the X variable is going to be called my scheduled, SCHED, and my spelling is always terrible. So I do invite you to let me know whether my spelling, if I made another mistake in spelling, which seems to happen seemingly on a daily basis. Scheduled arrival time, scheduled departure time, and scheduled arrival time. I think I've got those things correctly down here. Okay, so now, so this is my aesthetics function right here. And so that means that I'm figuring out where my X and Y coordinates are going to be and how to decorate them. Another option that I'm going to pass along to geom line here is I'm saying, well, if you're going to be doing the geom line, give me the color red. And I think that could be it. One more thing that I'll do, just for show here, I'm going to make a Y label, and I'm going to put as my Y label. I'm just going to copy this and edit this text over here. But this is like my you know, so I can see what this stuff is. So I'll just say versus. Let's do this. Maybe I'll make this a bit more cleaned up a bit. And I hope this thing actually does plot in some good time here. Otherwise, I'm going to be. Okay. So I'll just run this thing. I'm crossing my fingers on my right hand. I'm crossing my fingers on my left hand. You can't see this, but my toes are also crossed. Aha! Cool. So now we have this plot, which actually looks quite stunning, I think. This is actually quite stunning. Now, let me just ask you this. This is the dilemma of the data scientist. We have created this plot, and we now know that there is apparently some pattern that exists, but we don't know what that pattern is. And the pattern appears to be this rising line that goes up, up, and up, and you have these kind of like pieces of these kind of clutters of, or these kind of clusters, I guess I should say, clusters of information. But then when you get to this part here, this I guess it's around 1900 hours, then you have these long lines that spill down to the bottom. So how do we explain this? What's going on here? Well, the thing is that when you're doing data analytics, your graphs never do they never try and explain themselves to you. Instead, what they do is they try and get They try and tell you that there's something going on, and it's up to you to explain that. What's actually happening here is this is the rollover effect. This is the scheduled departure time by the scheduled arrival time here. And so when the departure time arrives after like midnight, then the rollover is going to be on 1 a.m. or 12:01 the next day. And so that means that the numbers on your scheduled departure time are semi-reset back down to 0. After all, these numbers here that we see, this 500, 1,000, 1,500, 2,000, those are actually hours. There's 5, 10, 3 o'clock, and 8 o'clock, and then midnight. And so that's how the data is put together. And we wouldn't have known that if we didn't see the actual code book for this data. But these are actually times that we have here. And so when a flight is delayed after midnight, the arrival time is going to be, if a flight is delayed before midnight, the arrival time is going to be after midnight. So that means that your arrival time is going to be a small number again, which really means the early hours of the next day. And so that is the kind of thinking that you have to do. You have to go through in your mind and think, well, how do I explain this graph? And so that's one possible explanation. Now, of course, I say one possible because maybe that's not the answer. Your job as a data scientist would then be to go back and investigate and actually, prove it to yourself, prove it to your colleagues that this is actually the way that this is actually the answer. Well, that's just what I'm putting out, and I think that that's probably good enough for this. The next plot is very similar, so I'm going to be lazy, and I'm going to just go ahead and copy this, and I'm going to go back down to the next one here. In fact, what is the next plot? Departure time versus arrival time. And so it's not scheduled any longer here. I'm going to be putting, let me just get this out here. This one I believe is going to be in blue. So we're looking at the departure time versus arrival time in blue. And what are we doing here? I think that's about it. Devise an explanation. So again, we have to figure out what's going on. Now, let me just draw your attention to this part down here. This is a dilemma of data. I always call it the dilemma. What it's saying is that it removed 8,255 rows containing missing values. In other words, the data had missing pieces, so you couldn't use missing pieces. And so that means that your information now has been compromised. But that's okay, it still works. This is the same type of graph here. Now we're just looking at the, in fact, I didn't change this information. I should have changed that, I apologize, but I should change that. But we're looking at not the scheduled time here, but the actual time that the flight took off and arrived. And again, if the flight took off after or just before midnight, it arrived shortly after midnight, and so that's why we have this rollover. Now, the next thing on this, I believe, is to combine both of these plots together so that we can make a kind of a comparison and see, is there, well, as I said, is there a correlation between both of these plots? In other words, does it look like the data, both sets of data is telling something of the same story? And so what I'm going to do is I'll just copy both of these pieces of code right here, and then I'll show you how to edit this code. Let me move this down a bit so I have more space to work. And so I have this, and so what I'm going to do now is I have to leave this information right here. The flights information is there. I don't need to establish this twice, but I do need this geom_line function there for both of my plots here. So I'm going to just remove that, and this is going to look like a mess. And I do apologize for making this look so crazy, but maybe I can kind of spread things out here. So I have my, first of all, I have my flights information here. I have my first line, which is the red information. I have my second line here, which is going to be the blue information. And then what I could do is I could update this. I can update this. I can update this. Let me just put this in here. Whoops. Okay, so the scheduled department time is, oh, that's going to be red. You need to update this information over here, and the other one's going to be blue. Just so you can see what's going on here. And hopefully that would be sufficient. Now, I recognize that I look like I'm flying through this, and we are over time. I will give you these, I'll just put this after class, I'll put this in the bin so you have this to reflect over. But you can see, I just want to get this one out. The other ones I'll give you later on when you get the solutions. But again, you see that the pattern is the same. And when you have one graph overlaid on the other, there's in fact, the blue is covering the red. And so you can see that actually there's nothing, there's no difference in the pattern here. So this is a visual representation of what they call a correlation. In fact, I'll go ahead and just change this around here so that now what was red was blue and now what's blue is red. And you'll see now that the graph will be red, and maybe if anything is blue, we might see that more clearly. It's taking some time to come through. It may not come through for a bit. There we are. So again, you can see that the blue is hidden squarely behind the red. And so what that suggests to me is that these two pieces of information are actually almost entirely, well, actually they are the same information, the same source. It's not a coincidence to have information that's so similar. Of course, we know what's going on because we created these plots. But if someone showed you a plot like this and they said, are these things the same kind of data? Yes, they are. Anyway, I don't want to keep everybody here. I know that we're over time here. Actually, class gets out at 25 after, but it's already 28. I do apologize for keeping everybody over. If you give me about an hour or so, I'll put these notes out onto your class docs so that you have them. Please don't forget to submit your practical so I can give you points. If you don't submit your practical or you don't submit whatever you have today, then I can't give you any points. That's just the nature of the beast. But you will have this code to guide you as you finish up the rest of these problems on your own.